Hello, class. This is the lab lecture for the Molecular Models and Chemical Bonds Laboratory. Now, I regret that you're not able to do this lab in person. It's actually quite a fun lab. You get to use little balls and sticks, and we get to construct molecules. And I find it to be a really great way to learn the structures of models and just what they look like, and it helps to be able to visualize it. So the path we're going to take is we're going to take a look at the periodic table. We're going to review Lewis dot formulas of atoms, or Lewis dot structures of atoms. And you'll notice that we're specifically hanging out in the carbon, nitrogen, oxygen, and fluorine world, this first row, or actually it's the second row. And then the remaining first four halides as well. After we do some Lewis dot formulas, we'll do of the atoms, we'll do some Lewis dot formulas of the molecules, and we'll show how you can pair up electrons to form a bond, which will help us to draw the structural formula. I will be doing 3D structures to help you visualize what these structures look like, bring life to them. And then the lab report will consist on pages, starting on page 145 through page 1 through page 150. You will be counting out the number of valence electrons. You'll be doing a Lewis dot formula of the molecule. You'll be doing a structural formula of the molecule. You will ignore the first column, and we will not do the molecular models, but I will still demonstrate the modeling to help you see what these look like. Let's go back up here to the top. So when we're talking about molecules, remember that you have effectively learned two types of bonding. We talked about ionic bonding. And the example that I used was sodium. Sodium, which has 3 orbitals of electrons around it. And in the inner row, there are 2 electrons, hence there being 2 elements in the first row. So this is your first row orbital, 2 atoms in that first, or 2 elements in that first row. Here are the electrons associated with those first elements. And then the second row, there are 8 elements. And each time we add a proton, which defines the identity of the element, we add another electron. Until that row is complete, or this orbital is complete. And then you end up with 1 electron in the third energy level, or the third orbital. So you see sodium is in the third row, or the third row is in the first column. Here's this outer orbital is the orbital where the electrons would set as we continue to add protons moving across the periodic table, thus changing the identity of the element. And here's that first electron. Okay, so we've done this before. And we also know that chlorine is here. And which means it's in the third row. So there are 3 orbitals. We know that the first orbital is completed. So it has 2 electrons. The second row is completed. So it has another 8 electrons. And it's in the next to last row here. And so what you've realized is that it's missing 1 electron from being like argon. And so in this ionic bond, this is, if you recall, this is where 1 electron is transferred, and you end up with a positive sodium and a negative chloride. So we've done that. So that's ionic bonding. Now, we've also done covalent bonding. And in covalent bonding, the example that I used in class was I drew oxygen, and oxygen's in the second row. It's the second from the last element. So it has 6 electrons in that outer energy level. So notice I put 1, 2, 3, 4, and now there's 5, 6. So there's 6 all day. How do I do that? Now, actually, let me do this a different way. I'm going to do this slightly easier. So I'm not going to worry about these the completed energy levels. I'm only going to draw the electrons in the outer energy level. So if we look at this periodic table, we see that oxygen is here, and it's in the 1, 2, 3, 4, 5, 6th column, and that tells us that that oxygen has 6 electrons in its valence in this outer energy level. So these are 6 electrons. These are we call those valent electrons. Valent, remember, this just means outside. So there are 6 outside electrons on oxygen. Now, I'm going to ignore this inner row here, and I'm just going to populate these here, but I'm going to do it in a way where here's 1 electron, there's 2 electrons, there's 3 electrons, there's 4 electrons. Now, if I was to keep going, these electrons, excuse me, I just hit my erase button. These electrons will pair up. So now there are 6 electrons around oxygen. If I was to draw a carbon, carbon is in the, carbon is in the 4th row here. And carbon has 1, 2, 3, 4 electrons. Now let's say that we have another oxygen here. So I'm going to draw another oxygen here. Now, you can imagine oxygen and carbon entering into a sharing arrangement where they share these 2 electrons. And maybe they'll share these 2 electrons. And in doing so, oxygen has access to 1, 2, 3, 4, 5, 6 of its own electrons, but it also gets the 7th and an 8th electron that is sharing from carbon. Similarly, I'll do this in a different color. Carbon now has 1, 2, 3, 4 of its own electrons, plus it has a 5th one and a 6th one that can share over here. If we do this again with this other oxygen, and if we share these unpaired electrons here and here, carbon would now have a 7th and 8th electron that it's sharing. And in both instances, oxygen now has 8 electrons that is here, has 8 electrons that it has access to, and there's your octet. Carbon has 8 electrons that it has access to, and there's this octet. And now oxygen and carbon both have full octets and they're happy. Now, what we've done is we are sharing between the valent electrons here and the valent electrons here. And anytime you're sharing, you think about cooperation or collaboration. And the reason why we call this a covalent bond is because it's really a collaboration between the valent electrons of carbon and oxygen. And so because there are valent electrons from both atoms coming together to form a bond, that bond is covalent. It's formed collaboratively, cooperatively from the valent electrons from 2 different atoms. So now you may also recall these covalent bonds lead to molecules. Ionic bonds don't. They really just lead to ions, or they lead to ionic compounds. But unless you're dealing with a polyatomic anion like sulfate or nitrate, you're not dealing with molecules. You're dealing with ionic compounds and ions. So when we're thinking molecules and molecular models, when we're thinking about molecules in the context of molecular models, you're thinking that, yeah, we're going to be working completely with nonmetals because nonmetals give us covalent bonds. And covalent bonds give us molecules. Okay, so let's first talk about the Lewis dot formulas of atoms, because I believe that it will help you do the Lewis dot formulas of molecules, which can then help you do the Lewis dot formulas of, or the structural formulas, okay? So in your book, if you turn with me to page 138, 138, they give an example of chloroform. Let's draw myself a little box here just to kind of make sure I'm staying in my range. That's not how to spell that. Chloroform. Chloroform's formula is CHCl3. And if you look, they don't do it here. Yes, it did. If you look on page 138, it says draw the structural formula and the electron dot formula for chloroform. And it really kind of highlights and bolds this C. This C is your central atom. The hydrogen is connected to it, and all of these chlorines are connected to it. So in my model set, chlorine is green. Chlorine is green. Hydrogen is white. Oxygen is black. So we can take, if you notice on this carbon atom, there are 1, 2, 3, 4 holes. So I'm going to draw, I'm going to put 4 bonds because I have 1 hydrogen and 3 chlorines. I'm going to create a bond for each of them. So there is carbon with 4 bonds. And I'm going to put a hydrogen on here. And then I'm going to put my 3 chlorines on here. And already you can start to, excuse me, last chlorine. You can start to see this 3-dimensional structure. We call this a tetrahedron. But you'll also notice that there are holes for the chlorines. So what's going on here? Well, let's keep drawing because I find that it's much easier. Well, it's easier to draw if you have a pen. It's much easier if we look at what's going on. So let's draw, first of all, let's draw the Lewis structure of the atoms. All right, so here's carbon. Carbon's in the fourth row. And we just start populating it with electrons as we go around, and they're unpaired. Remember, electrons are negative, and so they don't want to be next to each other unless they have to. Hydrogen only has one electron. Chlorine is in the seventh row, so it has 1, 2, 3, 4, 5, 6, 7 electrons. Now, these are paired electrons, and these paired electrons, we don't really mess with those. And I even have little paddles that kind of demonstrate the paired electrons. So you'll notice that chlorine has 3 paired electrons. 1, 2, 3 pairs of electrons. These little Mickey Mouse ears. And each one of these represents 2 electrons, and they're non-bounding because they're already paired. The only way we have a bond is whenever the unbonded electrons pair up. So now I have lone pairs of electrons of that chlorine. I can do it on this one as well. And so now you see all of these lone pairs of electrons around chlorine, and you see hydrogen here, and you see it still has this tetrahedral shape. So I could literally just sit it down on my hand if I turn this one guy around. I could sit it down on my hand, and it would form a little tetrahedron. When I say tetrahedron, I mean a pyramid connecting each one of these atoms rising up to the top. There's your pyramid. So, how do we draw the Lewis structure of CHCl3, the molecule? Well, if we take carbon, which we know is here, has 4 electrons around it, and we put that hydrogen up here, and we put that second electron, we now have a bond. And if we take chlorine with that one unbonded electron there, and put these other 2, these 3 pairs of unbonded electrons around it, we now have a second bond. So we have a bond here between hydrogen and carbon, and we have a bond here between chlorine and carbon. If we do this one more time, putting that orienting this unpaired electron here with this remaining paired electrons around it, we now have that last bond. And I'm going to color code this a little bit. So here's an unbonded electron, and here's an unbonded electron. This is where that unbonded electron for hydrogen would be. This would be where the unbonded electron for chlorine is. And here's a last unbonded, the unbonded electron of the last chlorine. And that is, and you don't really have to worry about the surface, but this is the Lewis structure for this molecule. Another way you might draw it is like this. This is how I used to draw it, and I prefer it this way, is to, if I draw carbon, as such, sometimes it's easier whenever you can see the chlorine with its unbonded electron here, and this bonded, unpaired electron there, and the paired electrons over here. This is a very helpful way of drawing it as well, because you still get the pair, you still see the pairing of the electrons to form a bond, but you can see that chlorine has this unpaired electron. You can see which of electron is unpaired and which one's paired. And what I like about this is this really ties in well with the third part, which is the structural formula. Well, I'm just going to take each one of these dots and make it a line. And now what you have is carbon with a line to chlorine. And I'm going to do the same thing with these guys as well. So I'm going to make each one of these lone pairs of electrons just a little dash. I totally apologize. I just realized I did a chlorine up there, and that really should be that should be a hydrogen. And I did this upside down. I'll reverse this. So I took each pair of dots and made a line. And I did it for the bonds and I did it for the lone pairs of electrons. And this to me is a good structural formula. Now, if you read the instructions in the book, it doesn't show that you have to do the lone pairs of electrons for the structural formula. I've always done the lone pairs of electrons for structural formulas, and I think it tells a good story because you can see. Excuse me. Because it allows you to see the bonds over here, see the bonds over here, or whichever orientation you do, either with electrons side by side or where they're still kind of on their own atom. You can see the bond, you can see the lone pairs of electrons, but you can still see them there. So effectively, all you're doing is taking the dots and making them dashes. And it's just an easy way to draw it. So that is really what you're going to be doing. The last step, the one thing that I did not do that you'll be doing in your lab report is counting up the number of valent electrons. They call them valence electrons. Well, if carbon has 4 valence electrons, hydrogen has 1, and chlorine has 7, but there's 3 of them, then that equals 21 plus 1 plus 4, and that equals 26. And we should be able to count those out up here. So is that right? Seven, 14, 21, 22, 26. 2, 4, 6. Yes. Yeah. Totally right. Okay. I'm back. Sorry, I got stuck for a second. So we should be able to count these out. We should go, okay. Here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 22, 24, 26. So really, you can do it any way you want. You could do valence electrons first. You could do the Lewis structures first. It doesn't really matter. Either one's going to be fine. So let's do one more example. Let's go to page 140. No, 139. So turn to page 139. We're going to do another example. We're going to do this a little bit more like your lab report. So in the lab report, you're going to be doing the valence electrons. You'll be doing Lewis structure. And you're going to be doing, all right, Lewis formula. And you're going to be doing a structural formula. And we're going to be working with, in this instance, H2CO. All right, so let me grab, here's, that's nitrogen. What color is oxygen here? Oxygen is red. Okay. So I have an oxygen. I have a carbon. It's H2CO, and I have two hydrogens. Okay. So let's put this together. Let's do it this way. Let's put it together. Let's go. Okay. So I'm going to put together my hydrogen. So I got one hydrogen here. I'm going to put a second hydrogen on here. In the book, it shows you that this carbon is really bolded. So this is the central atom. That's how I know that both these hydrogens are on here and this oxygen is on here. Okay. Now, what you'll notice is I have two holes here and I have this oxygen over here. Now, I'm going to put one bond between them. I'm just going to stop. I'm going to look at this for a second and go, is this correct? Well, let's draw this. So we have carbon. Carbon looks like this. It has 4 valence electrons. I have 2 hydrogens. Here's a hydrogen. Here's a hydrogen. That's 1 valence electron there and 1 valence electron there. And I have oxygen, which looks like this. And that's 6 valence electrons for a total of 6 plus 4 is 10, plus 2 is 12 valence electrons. Now, if I draw what I did here, I have carbon, which should look like this. I have 1 hydrogen on there, so I have my bond. I have another hydrogen here, so there's my bond. And what I did was I just put 1 oxygen, one bond between the carbon and oxygen, and that's all I have. And if I count this out, I have 1, 2, 3, 4, 5, 6. I have 7 electrons, which means I am 12 minus 7, 5 electrons short. And I need to find a place to put those electrons. I'm going to clean this up just a hair. Well, where can I put the electrons? You always put these extra electrons on the outer atoms first. So I have, and you can tell I'm missing a bunch here. I only have 1 electron, but I need 6. So I'm going to put 1, 2, 3, 4, 5 more electrons around oxygen. So now I'm caught up. But do you see how I have this unpaired electron? Well, these are going to bond together. So let's see what that looks like. Now, I'm going to replace this little short bond with a longer bond, and you'll see why. So I'm going to pop these in together, like that. And then I'm going to take and I'm going to put a second bond in there. And it should pop right in. It should, but my hands are apparently a little clammy. There we go. So do you see how I've put 2 bonds there? But I'm missing those lone pairs of electrons. So let's get a couple of lone pairs of electrons in there. So there we go. This, also put it down. This, what we see here, oh, you can't see nothing. Oh yeah, you can see nothing, right? This is what we see here. So we have basically this right there. There it is. Carbon is bonded to 2 hydrogens. It has that lone pair of electron, or the double bond here, and then the lone pairs of electrons. So Here's our Lewis formula. And let's make this into a structural formula. So all we're going to do is make all of our dots into lines. So we have carbon with a hydrogen and a hydrogen double bonded to an oxygen, which has 2 lone pairs of electrons around it. Now, each one of these is 2 electrons. So I got 2, 4, 6, 8, 10, 12. And that checks out. So just to recap, what we're going to be looking for is I have 12 valence electrons. The structure looks as such. The valent or the Lewis dot structure. Well, let me back up just a hair. To make this look a little bit prettier, we're going to put those, to do the Lewis structure, we're going to put both of these paired electrons between them. And then the structural formula will be as such. And again, I like to put my lone pairs of electrons around it. And this is formaldehyde, is what that is. So now turn over to page 140, and we'll do the last example. In the last example, it's HCN, and this is bold because it's the central atom. Okay, so we can do it a couple of ways. We know that hydrogen has 1 valence electron, carbon has 4, nitrogen has 5. Well, I think you're beginning to see nitrogen wants to have, excuse me, what you may be beginning to see here is this. Here's carbon, here's nitrogen, here's oxygen, and here's fluorine. Here's carbon, here's nitrogen, here's oxygen, and here's fluorine. We haven't talked about fluorine much yet, but here we go. Notice that you have 4 unpaired electrons. You have 4, 3, 2, and 1 unpaired electrons. Each one of these becomes a bond. So the number of bonds each one of these wants for carbon, nitrogen, oxygen, and fluorine is 4, 3, 2, 1. And the number of lone pairs of electrons. Here's 1 lone pair of electrons. There's 0 here. There's 2 lone pairs of electrons there. And there's 3 unpaired electrons here. And we're going to call these LPEs. LPEs. Lone pairs of electrons. This is a common theme in molecular models. 4, 3, 2, 1, 0, 1, 2, 3. And this becomes a really nice shortcut. So when I look at this, I can immediately start putting together and say, okay, carbon wants to have, now, and this is going to be the exception. Carbon needs to do something with all these electrons. So here's hydrogen. And here's nitrogen. We're not going to do anything with those, but each one of these will pair up. And what you'll have is carbon bonded to nitrogen, or hydrogen, with 3 bonds to nitrogen in a lone pair. So what do we have? 4 bonds on carbon, 1, 2, 3, 4. 3 bonds on nitrogen. 1, 2, 3, and 1 lone pair of electrons. Check. It fits that rule perfectly. 4 bonds on carbon, 3 bonds on nitrogen, 1 lone pair of electrons. And so do you see how, like, very quickly, just by looking at the formula and knowing the number of valence electrons, I was able to draw the structural formula. Now I can draw the Lewis dot structure by going from each line to 2 dots. What I'm hoping that you see is, I'm hoping that one, you do more than just complete a worksheet. I hope that you see that it doesn't matter. It's kind of a chicken and egg argument. Like, you can do it however you want. You can either do your valence electrons first, you can do your structure first, or you can do, I lost my pen again, or you can do the structural formula. Okay, so I'm going to go through each one of your molecule of your structure that you're supposed to do on page, starting on page 145, and I'm going to construct them for you so that you can see them. Let me get the pages back together. Okay. So I want to do this. Yeah. Let me stop this. And here we go. Okay. So the first compound on page 145 is hydrogen. Now, each one of these, here's my bond, and here's my structure. Hydrogen has 1 lone pair of one electron. When you have 2 hydrogens, the 2 electrons are paired up into 1 bond. So here's your molecular model. You don't have to draw that, but you do have to write down the number of valence electrons. Each hydrogen has 1 valence electron. And you have to draw the Lewis dot structure, where you have each electron either paired up side by side or paired up vertically. It doesn't matter which one. And then you draw those, take those 2 dots and make a line out of it to form your structural formula. So here's hydrogen. Chlorine, green. So here is number 2 is chlorine. So here, oops, excuse me. Yep, here's chlorine. So notice chlorine, like fluorine, wants 1 bond and 3 lone pairs of electrons. Each one of these is 2 electrons. So you can see chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. It contributes 1 electron to this bond. The second electron contributed to this bond comes from this chlorine. So it has 1, 2, 3, 4, 5, 6, 7. So this is the structure for chlorine. Similarly, bromine, because it's in the same column as chlorine, effectively looks identical. So in my model kit, chlorine is brown. Sorry, bromine is brown. And now we're in part we're C, and here's bromine. Notice the 2 paired electrons, the lone pairs of electrons, the 1 bond consisting of 2 electrons, 1 from each atom. Valence electron count, because it's in the 7th column for bromine, is 7. There's 2 of them, so you can calculate how many valence electrons there are. You can pair these up for your Lewis dot. You can draw a line for your structural, but here's your molecule. Let's do iodine. In my model kit, iodine is purple. I recommend hitting that forward button on the video so you don't have to necessarily just watch me do each one of these. And here's iodine again. One bond constructed of each unpaired electron from each iodine, and then each one of these lone pairs of electrons, iodine, I2. All right, so now let's do chlorine. Here's HCl. Here's your HCl. This is what your structure should end up looking like as a Lewis dot and as a structural. Here's the lone pairs of electrons around chlorine and the bond around bond between chlorine and hydrogen. Here we have HBr. Remember, two electrons, they're always paired up. When you see them shown like this, so there's a pair of electrons, one from hydrogen, one from chlorine, paired electrons, the paired electrons around chlorine, around bromine. And then we have iodine, finally. So now we are in letter G, and we have, oh, sorry, letter G is ICl. Okay, so here is I, and we need a chlorine. Now there's all these holes here, and we're going to fill those holes up. Again, you can look at the periodic table and see this in the 7th row that has 7 valent electrons. And so we have to populate all those pairs of electrons around chlorine and around iodine. So your Lewis structure should look something like this with dots. Dots here, either 2 dots side by side, or you can put them vertically. Let's do letter H. CH4. Notice the C is bold. So here's my C. I have 4 hydrogens around it. Now, if you're in an advanced class, you'd have to understand the 3D structure of these, but hopefully you'll be able to at least appreciate. Here's my CH4. This is that pyramid I was talking about, where these three hydrogens create the base. This was at the top. There it is. 8 CH4. Now we got CH2 Cl2. So I'm going to take 2 of these hydrogens off, but we're going to leave the bonds just to make it easy. I'm going to put 2 chlorines on here. And then I'm going to fill up all the holes on the chlorine with lone pairs of electrons. And there's my H2 Cl2. What's next? On page 147, we have HOCl. So that O we see is bolded. So that means that O is in the middle. We're going to have 1 bond to a hydrogen, and then we have 1 bond to a chlorine. Well, we can look at this and say, oh, there's 2 electrons here and 2 electrons there. That's only 4 electrons. Oxygen needs 8 electrons. And so we're going to just fill in that extra space around oxygen with these lone pairs of electrons. And there we have HOCl. There's three unpaired electrons around chlorine, two around hydrogen. Now let's do K, H2O2. Okay, well, here's H, O, here's another O. And in this instance, the O is bolded, but what it's really trying to say is that you have this HOOH, H2O2. Notice that we have two holes around the oxygen. We're going to fill those in with lone pairs of electrons. And really, because these electrons are negative, they don't want to sit like this. They're actually going to sit opposite like this. And so this is from peroxide, NH3. So now we're going to find our nitrogen. And in nitrogen, I'm actually going to continue, I'm going to use this green one for nitrogen. So it's NH3. So we have three hydrogens around it. So we'll pop those in. We're going to go, oops, excuse me. One bolt. So here's nitrogen. It's got three hydrogens around it. One, two, three. There's two electrons being shared covalently between between nitrogen and each of these three hydrogen atoms. But that only gives me six electrons around nitrogen. So I'm going to give it one pair of unpaired, or one set of unpaired, one set of paired electrons into H4. Okay, so we're going to need two nitrogens, and I'm going to use green again for nitrogen. And here I have nitrogen with two hydrogens on it. I have my other nitrogen with two hydrogens on it. Nitrogen likes to have three bonds and one lone pair of electrons. So now we have, excuse me, we have N2H4. We have 2, 4, 6, 8, 10 electrons. But nitrogen likes to have three bonds and one lone pair of electrons. So I'm going to give it this lone pair of electrons. And just to be precise, because these are negative, they don't really want to be next to each other like that. So we're going to invert it. And so this becomes what, and this is hydrazine, N2H4. This is what rocket fuel used to be made out of. Now we have NH2O4. So we have NH2, sorry, NH2OH. The N you see is bold. And so there we go. Here's N2, NH2OH. Now, when you see this, the OH group is always one group with the oxygen in the middle. Notice that nitrogen has three lone pairs or three bonds and one lone pair of electrons. Oxygen has two bonds and two lone pairs of electrons. Now, if you notice at the top of 148, it says molecules with double bonds. All of these previous ones were molecules with single bonds. Now let's do a molecule with a double bond. So it says that O2 has a double bond. Now we know that O2, that oxygen likes to have two lone pairs of electrons, and it likes to have two bonds. Well, in this instance, these bonds are going to come together, just like this. There we go. Here is oxygen. Four electrons between the two electrons here is a bond, two electrons here is a bond. Two sets of lone pairs of electrons. Just like that. C2H4. So we know that there's going to be a double bond. Let's go ahead and just assume that that double bond is in between will be between the carbons, just like it was between the hydrogens. And what you start off with is carbon with two bonds, two electrons here, two electrons there. Now we need four hydrogens. So we're going to have one, two, three, four, just like that. What's next? HONO. All right, we're going to go back to nitrogen, and it's going to have two oxygens on it, one with a hydrogen. Well, we know we're going to have a double bond, so let's put a double bond between nitrogen and one of these. There we go. Nitrogen with one double bond to an oxygen, and then we'll have a single bond to an oxygen, which has a hydrogen on it. So you have nitrogen, oxygen, that's your double bond right there, and then the nitrogen to the OH group here. So now we're going to do COOH. Now, notice that the carbon is bold, and so we're going to have, here is the OH on that carbon. So now we have this HCOOH. Here's the hydrogen, and here's the OH group. Now we just need a double bond between the carbon and the oxygen. So H, let's look at it. Letter D, page 148. HCO, sorry, HCOOH. Now we have C2H3Cl. So we have C2. We're going to put a double bond between those two carbons. C2, and then it says H3Cl. Well, there's two hydrogens. There's a third hydrogen. And let's put 1/4 atom here. Here's a chlorine, and then remember the chlorines have 3 lone pairs of electrons on it. Double bonded carbons, CO, or 2 C's, C2, 3 hydrogens, H3Cl. Now, we're in the home stretch here. We got 5 more. If you look at the page of 149, it says we have molecules with triple bonds. So the first one is nitrogen, and it says a triple bond. All right, well, let's put, and we know that nitrogen likes 3 bonds and 1 lone pair of electrons. So we're going to put a single bond, double bond, triple bond. This is why nitrogen, like hydrogen, nitrogen, hydrogen, chlorine, bromine, iodine, and oxygen and fluorine are all diatomic molecules because they literally form 3 bonds, one lone pair of electrons on each, or in the case of oxygen, 2 bonds and 2 lone pairs of electrons, or hydrogen, 1 bond, no lone pair of electrons, or fluorine, 1 bond, 3 lone pairs of electrons. This is why these are all diatomic, is because this is such a stable structure. Letter B is, it says C2H2. All right, So I got C2H2, but it's a triple bond. So I'm going to put this last triple bond right here. So there we are, 3 bonds around between the 2 carbons, 1 single bond between the carbon and the hydrogens. The last one is HOCN. Okay, so we need, let's do the OH first. Here's the OH. Here's the HOC right there. And it says HOCN. So I'm going to take my nitrogen with that 1 lone pair of electrons, and I'm going to pop in 3 bonds to it. And what you'll find is carbon in a very stable state of having 4 bonds, 1, 2, 3, 4. Oxygen has 2 bonds and 2 lone pairs of electrons. Oxygen has 1. Nitrogen has 3 bonds and 1 lone pair of electrons, and then we have a stable structure. Now we have, in part D, molecular models with 2 double bonds. And the first one is CO2. So let's get our oxygen in here. It likes to have 2 lone pairs of electrons. So here's our first CO. And here's our second oxygen with 2 lone pairs of electrons. And here we go. 2, 4, 6, 8 electrons around oxygen, octet filled. 2, 4, 6, 8 around, the carbon, now oxygen. 2, 4, 6, 8 around oxygen. 2, 4, 6, 8 around, dang it. 2, 4, 6, 8 around carbon. 2, 4, 6, 8 around oxygen, oxygen there. So we have the stable number of electrons. Everyone has an octet rule filled. Everyone's stable. Then we have C3H4. So we need to. We know that there's going to be 2 double bonds. So let's just take these carbons out, or these oxygens out, and we'll put in a carbon on both. So we have C3. Here's our C3. Notice it's got the middle guy's already ready to go. 2, 4, 6, 8 electrons around that carbon. He's doing well. But now we need, there's 2, 2, 4, 5, 2, 4, 6 electrons here. Now there's 8. If we do the same thing over here, we have C3H4. So for each of these, you'll write down the number of valence electrons. Notice that each bond is 2 electrons, so 2, 4, 6, 8, 10, 12, 14, 16. Or you can count it based upon the number of valence electrons of each atom. So carbon always has 4, 4, 8, 12. Hydrogen always has 1, 13, 14, 15, 16. Either way, you get to the same number. You've seen the structure in 3D with the model. So you know that there's going to be either 2 dots for each one of these, side by side for your Lewis dot. 2 dots here, 2 dots there, 2 dots there, 2 dots there, 2 dots there, 2 dots there. Or there's going to be lines between them. 2 lines, 2 lines, 1 line, 1 line. And that's it. The last step is that you'll have to go into Canvas, and under Canvas, there's going to be a PDF with your unknowns in it, and you'll have to, and there's five unknowns, and just do the first 4. So even though there's 5 unknowns, just do the first 4 unknowns, and I will show you where those are right now. Okay. If I can find the right screen. There we go. Okay, so home. When you scroll down, you'll see under the molecular models and chemical bonds, molecular model unknown. Boom. And let's see if we can make this big. There we go. So it gives you the key, and theirs is a little bit different than mine. Mine was brown for bromine, but it was green for chlorine and purple for iodine. We use different colors for nitrogen, but mostly they're the same. And so you'll see here's 3 chlorines and a hydrogen around oxygen. That's unknown number one. You'll identify the you'll identify the atom. So these are all chlorines, and chlorine has 7 valence electrons, and there's 3 of them. Here's carbon, and here's hydrogen. So when you'll write down that formula, which in this case would be CHCl3, you'll do the number of valence electrons. You'll draw the structure out, both with Lewis dots and with the structure with the lines. Here's the second one. So this is nitrogen in blue, carbon in black. They don't show the lone pairs of electrons like I do. There's still a lone pair of electrons here. And then all of these are hydrogens around it. So this is CH3NH2, or H3CNH2, as you wish. Here we have carbon, carbon, oxygen, hydrogen, hydrogen. So this is CH3CH2OH. And then the fourth one, I believe that's bromine. So you got bromine, chlorine, and 2 hydrogens. So you're going to do the Lewis dot structure, the valence electron, and the structure for just the first 4. Don't worry about the 5th one. And that is it. Please email me if you have any questions.